Last but not least, we're going to cover dividing radicals. So from yesterday, no radicals can occur in a denominator. So we must do what we call rationalizing, or we must rationalize the denominator to get rid of the radical in the denominator. So in order to do this process, in order to rationalize the denominator, you multiply by another radical expression. Or sometimes we use the conjugate, which you might remember from section C is the opposite. So for the examples down here, to get rid of the square root of 5 in the denominator, we need to multiply by something that will make it a perfect square in the denominator. So if we multiply by another square root of 5, that would give us the square root of 25 down there, which would turn into 5. So if you remember your fraction rules, whatever we do to the bottom, we must also do to the top. So when we multiply this, we will have 8 square root of 5 over 3 square root of 25. And like I said, the square root of 25 is just 5. So the top remains the same. We'd have 3 times 5, which is 15. If at all possible, you do want to reduce the numbers out front, the 8 and the 15, but since there's nothing that goes into both of them evenly, this will be our final answer. For example 8, we have a 4th root, and we have a 9x to the 5th there. So what you want to do is simplify that denominator as much as you can. So maybe we'll rewrite this as the 4th root of 4 over the 4th root of 9, we can rewrite as 3 squared. And then we have an x to the 5th underneath there. So, in order to rationalize this guy, what we're going for is we need to have a total of 4 things underneath the radical in order for them to be removed. So right now, we have a 3 squared down there. So how many more do we need to make that 4? Well, we need 2 more. So we need to multiply by 3 squared again. Then, right now, we have 5 x's in the denominator. And we could remove one group of them, but then you're still going to have one left in there. So what we might as well do is round up to the next whole number that 4 goes into. So in order to make a total of 8, because 8 is divisible by 4, we can multiply by x cubed, because remember when you multiply, you add the exponents. And again, whatever you do on the bottom, you need to do on the top. So we'll multiply by a 3 squared and an x cubed. So what we'll be left with on the top is the 4th root of 4 times 3 squared times x cubed. And on the bottom, we will have the 4th root of 3 to the 4th and x to the 8th. So now we are able to simplify. We could simplify the 4 on the top, turning it into 2 squared, but still the exponent is a 2, which is less than 4, so that means it's going to be stuck in there. It can't come out at all. So we can just multiply 4 times 3 squared, which is 36. And again, the x cubed is stuck in there because 3 is less than 4. And on the bottom now, that 3 is able to come out, and then we would have x squared because there are 2 groups of 4 inside the x to the 8th. And so now that we have no more radical in the denominator, this will be your final answer. We will save example 9 for class. And so to go on to example 10, this is a case where you're going to have to use the conjugate. So anytime you have two radicals, or actually, even if you have one radical in the denominator, so let's say two radicals or one radical separated by a plus or minus sign, you're going to use the conjugate. So for the problems up above, for example 7 and 8, we multiply by another radical expression, which is the first thing we wrote at the top. So for examples 10 and 11, we're going to have to use the conjugate, which is the second option we wrote at the top. So hopefully you remember from section C, conjugate means opposite. So the conjugate of square root of 7 minus square root of 3 is square root of 7 plus square root of 3. And again, whatever you do on the bottom, you have to do on the top. So, to multiply the top, we're not going to really do a whole lot. We're just going to put it together up there since we have two very different quantities. And then on the bottom, we're going to have to use our distributive properties. So we'll have the square root of 7 times the square root of 7, which is square root of 49. And then the square root of 7 times the positive square root of 3 is positive square root of 21. And negative square root of 3 times negative square root of 7 is negative square root of 21. And negative square root of 3 times positive square root of 3 is negative square root of 9. So, the reason we use the conjugate is so that these middle terms will end up canceling each other out. And we know the square root of 49 and the square root of 9. So again, the top is along for the ride. And in the denominator, we will have 7 from the square root of 49 minus 3 from the square root of 9. And again, you'll want to simplify that. So we'll have 2y times the square root of 7 plus the square root of 3. All over 4. And it does help to keep the top in factored form like that, so that way you can simplify at the end if you can. So we will have the 2 canceling with the 4 down there. So we'll have y times the square root of 7 plus the square root of 3 all over 2 as our final answer. And we will save example 11 for class tomorrow.